Hi, I'm Dan Christensen. I'm an additive manufacturing engineer with Relativity Space. And since you asked, how does DFAM work? How are you using DFAM techniques and topology optimization in your parts? Let's get into it. DFAM, or Design for Additive Manufacturing, is a process by which our design, analysis, and manufacturing engineers collaborate to produce a part that is well suited for the 3D printing process. Aerospace manufacturing has traditionally relied on subtractive manufacturing methods, which start with a large block of material and carve away metal until it produces the final part. This is like sort of carving a spoon out of wood. With 3D printing, we're building the part by adding material where it's needed, hence additive manufacturing. This creates alignment between our goals of minimizing part mass and print time, meaning that as a part becomes lighter, it also becomes faster and cheaper to print. Not having to worry about tool access also allows our designers to combine multiple parts with wildly different functions into single printed components, and this further reduces the number of bolted connections that we need to produce. Combining multiple parts into one also means that we have a lot of very large parts that require some of the largest 3D printers in the world. Two of our largest parts are gas generation chamber and main combustion chamber. They see some of the highest pressures and is comprised of only two main parts with a single bolted connection, which replaces several components and multiple leak-prone connections on a traditional manufactured engine.